I'm going to direct your attention to the inline array. That's the term they use to describe terminals that are in one line, like a line of charge, if you will. It's called an inline array connector, and it's in the upper right-hand corner. 3 of them correspond to a positive terminal, 3 correspond to a negative terminal. So you need one connected to the positive, one probe or one wire connected to the positive and one to the negative. This is where we need to connect to measure capacitance. So it's different fundamentally than we would use this device for other things. That's why a lot of multimeters don't even have this functionality. Up at about 2 o'clock, 1 to 2 o'clock, is the capacitance mode on the multimeter. Now, sometimes, I don't know why I have to, but I will explain in case you haven't used it. The scale units for each of those selections, those are not factors you multiply. Those are maximum deflection or maximum range of values. Kind of like when you have a scale that only measures 300 pounds. It doesn't mean that if it's a 300-pound scale that you step on the scale and take the reading and then multiply it by 300 pounds. This just tells you the maximum value. So as a general rule with any scale or any meter, you start with the lowest possible reading, sensitivity, and if that's too sensitive and you overshoot your signal, go up to the next, go up to the next. At the very, very bottom of the scale, the highest sensitivity are pico coulombs per volt. In fact, I should have probably told you what the units are for this thing. Coulombs per volt, the standard unit that we use. The farad. Coulombs per volt. We're going to start seeing kind of like an electric field is a Newton per coulomb. Well, a coulomb per volt is a... All of these are sort of interrelated. The volt is a joule per coulomb. There's a lot of this unit analysis you can do that Ian can appreciate will save you sometimes a lot of trouble when you don't remember an equation. Because your units, well, you can really see a lot by just following the units. It's kind of nice.
If that's coulomb per volt and volt is joules per coulomb, doesn't it just make it an inverse joule?
No. It would make it a coulomb squared per joule.
Okay.
The denominator is a little bit. So the scales are basically the little p, that's pico, 10 to the negative 12 farads. Nano, 10 to the negative 9. And you will not go that high, but the mu is microfarad sensitivity. So millionths of a farad. Okay, so we're going to measure pretty small capacitance, and we're probably going to be in the 20 nano range. Probably going to be a good place to be. So there you go. We'll get to discharge here in a couple weeks. So for now, capacitive discharge. The rest of it you save for Friday night.
Right.
Okay, so you'll need one of these. You'll probably need, in your kits, you'll have, in either the drawers or the cabinets, you'll have, there should be some wires. Because you can't use terminals, you have to use basic wire, you have to use thinner wires. In fact, come to think of it, I'll probably have wires for you to use. You do not need the power supply, I believe. So you don't need to bring that to your table. What you will need, though, and I don't know if it's in your kits or not, it might be in your electrical kits, you'll need 2 parallel plates. Stainless steel, just be careful, read the warnings, sharp edges. They're not sharp when you touch them, well, except maybe the corner, but they're really tight 90-degree angles. So if you run your skin across it, you can, in fact, put a pretty good slice. So they're fine to handle, just don't be sliding along them. Okay? Sheet metal. Sheet metal. fact, I suspect these were cut with one of those little sheet metal things, I forget the name they're called, but yeah. So, shears, they're called sheet metal shear. Okay, so the material that you'll put inside will be either one of, well, I don't want you to use those are dirty. Transparency film. I should have you do this with multiple materials, because you can do it with paper, even though it's a relative conductor. It's not a very good conductor. You can do it with paper, you can do it with any insulating material. But I'll let you figure out the rest of it for now. I'll come around. There'll be places where I'll need to give a little bit of sage advice, maybe. What's that?
Steel sheets.
Fine.